So these are some binary questions, data representation. So we've got a selection here. So the first one we're going to look at is representing the binary number 10110110 in decimal. So the first thing that I'm going to do is write down my binary positions, and hopefully by now you can remember what they are, but you'll notice they just double as we go up. And we only have to work with 8 bits at GCSE. So as far as this, so then I'm going to put my number in here, 1011 0110, and then it's simply a case of adding up the ones where we have a 1. So 1 times 128 plus 1 times 32, etc. So I've got 128 plus 32 plus a 16 plus a 4 and a 2. And remember, you don't have a calculator for this paper, so take your time. There's nothing wrong with writing this down. You don't have to do all this stuff in your head. That way we could make a mistake. So I've got 8, 10, 16, 22 in that column. I've got 8 there and just 1 in that column. So we've got 182. 182 is the answer. I'll just make it completely clear to the examiner that that's my answer on that one. So this one's for hexadecimal. So hexadecimal, remember, we've got the symbols 0 to 9, just like we have in decimal, but then we've got A is 10 and B 11, C 12, D 13, E 14, and F for 15. So, you know, no problem about writing those down on the side of your paper. You'll have time in the exam to do this. Write it down on the side of your paper to remind yourself so you don't make a mistake. So what's like representation of the decimal number 142? So the way I like to do it is to find out what that is in binary first. So again, I'm doing the same thing, writing down my binary pattern here. Like that. And then 142, so I've got 128, so I can take that away. So nothing to stop you doing this longhand. I've got 14 left, so no 64s, no 32s, no 16s, and 8. So again, I can take that away. That leaves me 6 left. 4, 5, 6. So we've got our pattern now in binary. So now we split them in half. So we've got 8, 4, and 2. That's 14. So 14 in hex is E. And we can just write these positions in again. 1, 2, 4, 8. So I've just got 8 there. So 8E. 8E is the answer for that one. So one reason that programmers often use hex. So why do programmers use hex? So remember, computers don't use hex. So computers only use binary. So binary 0 or 1 just represents the switches in the computer. So switches can be on or off. So we use binary for computers, but programmers sometimes use hex because we get a shorter representation on paper. And so we could say that it's easier for humans to read, perhaps. You know, we could have said it gives a shorter representation. So it's important to remember that it doesn't give a smaller or a shorter use of memory. The memory is exactly the same. So it's binary in the computer, so it doesn't make any difference. But for humans, it's easier for humans to read. It's not a very good writing of humans, that is it. So I would say in the exam, if you can do it the best you can, the examiner will be able to read it. That's a bit better. So it's easier for humans to read. It gives a shorter representation. So we've done 2 reasons for that. And they're always the best, easiest ones to say, really. So completing the binary addition. So adding binary, we can always say that we can just add binary the same as we do our standard numbers, but we can only go 0 or 1. So that's all the symbols we've got. If we've gone to get to 2, we've gone too far, we need to carry. So 0 and 1 is 1. 0 and 0 will be 0. 1 and 0 is 1. 1 and 1, or 1 and 1 would be 2. So the binary pattern for 2 is 1, 0. So 0 and carry 1. 0 and 0 and 1 is just 1. 1 and 1 again is 0, carry 1. 0 and 1 and the carry is 2. So that's 0 and carry 1. And so we've added up our number just like that. So you'll never be asked to add more than 3 numbers together in the exam. So if you can add this, remember this, the way it works, you should be okay. So obviously if we'd got some binary numbers like this, and we wanted to add them together, 1 and 1 would be 0 and carry 1. And then we'd get 1 and 1 and 1, which is 3. Well, the binary pattern for 3 is 1, 1. So that means it would be 1 and carry 1, like this. So if we've got 3, it's 1, carry 1. If we've got 2, it's 0, carry 1. Okay, so we move on. We've got a bit pattern stored in a byte. A byte is 8 bits. Bytes are 8 bits. Nibbles are 4 bits. It's a terrible computer joke, but it is also true. So what bit pattern will be stored in the byte after a left binary shift of 3 places? So we're going to shift left by 3 places. 1, 2, 3. So the 1's going to go in there. I'm just going to write the rest of my pattern in. Just like that. So we've just shifted across our pattern 3 places. I've just brought it down here and gone 1, 2, 3, moved it across 3 places to the left. And that's all we had to do for that question. So we've got another state the decimal representation of the binary number. So we just write our binary positions again. 1, 2, 4, 8, 16, 32, 64, 1, 2, 8. And then we're going to write our number in there. 1, 0, 0, 1, 0, 1, 0, 0. And then we just need to add up the 1 times 128 plus 1 times 16, etc. So I've got 128. I've got a 1 times 16, a 1 times 4. And that's it in this case. So I'll do my adding up. 18, 4, 1. So 148 is our answer to that one. So state the binary representation of the hex number BE. So at this time we're going from hex into binary. So again, let's put our numbers down. 1, 2, 4, 8, 16, 32, 64, and 1, 2, 8. And let's just, I was supposed to go to a different color, we didn't. There we go, we want a bit of green. So 1, 2, 4, 8 are our imaginary positions for our hexadecimal numbers. So BE, so if I've got B on this side, remember that A is 10 and B is 11. C at 12, D at 13. So I've got BE, so E is 14. So B is 11. So to make 11 on this side, I need 1 8, a 2 and a 1. That adds up to 11, 8, 9, 10, 11. And then on this side, I've got E. I need to add that up to 14. So 8, 12, 14, like that. And so that is my answer just there. But if I want to write it in here, write it into binary in this 1 0 1 1 1 1 1 0. So that's my answer in binary, and that's me converting from hex into binary.